So today's lesson is called Families of Quadratic Functions. We're going to focus and then I'll get back to you. So today's lesson is called Families of Quadratic Functions, but really it is a continuation of what we were learning last class because you're going to notice that we've actually talked about a couple of these things. However, there's one part of it that I don't think you learn in grade 10. It is a kind of a new grade 11 thing. However, if you did virtual school at a school other than this one, you may have seen it. So first, I just want to bring your attention to the fact that we have three different families of quadratic functions. There are the different types. So we have standard form, factored form, and vertex form. And within each one of these families, all of the parabolas in a certain family have a similar characteristic. So for example, in standard form, parabolas with the same y-intercepts belong to the same family because all of them intersect at the same y points. In factored form, parabolas with the same x-intercepts belong to the same family because they're always going through the x-intercepts at the same point. The only thing that changes is the stretch and compression. And in vertex form, parabolas with the same vertex belong to the same family. So our goal in today's class is we're going to be observing the letter A, and that's really the only thing that's going to be changing in all of these questions. And I also have to say, vertex form and factored form are very useful. Standard form is pretty useless for what we're going to be talking about today. Okay, so we're going to begin by trying question A, which says, is that a cat? That's a cow. Determine the equation of the parabola with the following characteristics. There are zeros of -3 and 5, and it passes through 3, -1. So the first thing I want to talk about is, what does the word zeros mean? And it means, oh, go ahead, everyone. Sarah? Yeah, it's the x-intercept. So whenever we're talking about zeros, we're actually talking about the x-intercepts. I have a little scale drawn on the side. I'm just going to sketch what's happening in this question. I know that -3 and 5 are two of my x-intercepts where my parabola is going to be passing through. And the other information they've told us is it's also passing through 3, -1. So let's say this is 3. Let's say this is -1. So around this point, it's passing through. That doesn't mean it's the vertex. It doesn't mean it's the lowest point. It could just be one of the points on the graph. So our parabola could look something like this. Okay, that gives you like the general shape of it. This is actually very not accurate looking at it. It's probably not going to look like this, but you just get the idea that it's passing through this point and the x-intercepts. Okay, so how do we solve a question like this? Well, first, let's note down all the important information. We know one of the x's is -3. Like one of the points is -3, 0 is what I mean. And another x is 5. So that point is 5, 0. And also, this parabola is passing through 3, -1. Do we have the vertex in this question? No. Can we use vertex form? But we don't have the vertex. So Rahiman, what's your question? I knew you were going to say that. You take all the joy out of all of my colors. There you go. Sarah? So when you wrote like exactly. Yeah, that's the point that the parabola passes through on the x-axis. Yeah. Okay, so we cannot use vertex form because we don't know what the vertex of this parabola is. So we have to use factored form. That is y is equal to a, and then we have a bracket, and then we have another bracket. Each one of these brackets contains one of the x-intercepts, but you change the sign. So if I know one of the x-intercepts is -3, if I change the sign, it's going to become x plus 3. How about the other bracket? X minus 5. Okay, so we now have some of our information filled, but we have too many variables. We have a y, an a, and an x, and we need to solve for a. Luckily, just like last class, we have a point, 3, -1, and we can use that point to put it into our x and y values. Sorry, Why does that do that? So we can use this point, put it into our x and y values, sub that into the equation to solve for a. Sarah? Yeah. So you know how when I'm going to put in the values. So y is -1, a is what we're trying to solve, and x is 3. You go all the way until you have an answer. So 6 and -2. This is -12. And so our a value is going to equal to 1/12. Where did I get what from? Did you forget that I have like the supersonic hearing? Can I tell you guys something really funny? Okay, so did you guys get a is equal to 1/12? Okay, now we need to actually put this back into our equation, and our final answer is going to be y is equal to 1/12 x plus 3 x minus 5. Did any of you guys learn this last year in grade 10? You did? Did you have a virtual teacher? Whoa, he taught you guys this. Did you? Yeah, go ahead. So question number 2 says, we want to find the equation of a parabola where the vertex is -2, -1, and we have a y-intercept of 10. So in this question, if I were to sketch what's happening, -2 is approximately there, -1 is there, and this time they tell you that that is the actual vertex of the parabola. So I know that is the lowest or highest point. It also gives you more information. It tells you that the y-intercept is 10. So that's really useful in us knowing the shape of the parabola. We know it's going to be going like this, and then probably, okay, pretend that goes through like this. As soon as I've been given the vertex, I know that the easiest form to use is going to be vertex form. So I'm going to write my information down. I know the vertex is -2, -1. And I know the y-intercept, the point is 0, 10, because in the y-intercept, the x is always equal to 0. We did this last class. Do you guys remember this? I actually wanted to backtrack though, because I recognize some of you didn't learn it and had a lot of questions from handout A. So maybe this will help like solidify the concept a little bit more. So when something is in vertex form, I use this form over here where I have the x part of my vertex inside of the bracket, and you change the sign. So if the x value of your vertex is -2, what are you going to put inside the bracket? Good. And then you put the -1 on the outside, but you don't change the value. You don't change the sign. So it would just be y is equal to a x plus 2 squared minus 1. Now, luckily in this question, we've been given another point. So we're going to plug that in and then solve. So 10 is equal to a 0 plus 2 squared minus 1. 10 is equal to a times 4 minus 1. I'll move that to the other side. So 11 is equal to 4a, and a is just going to be equal to 11/4. So our final answer is going to be y is equal to 11/4 bracket x plus 2 squared minus 1. Any questions about that? We're okay with it? Bea? So don't let the radicals scare you. Although if my last class is any indication, you guys have forgotten everything you learned about the radical unit. But hopefully this will jog your memory a little bit. So the question is asking, what is the equation of this parabola if the zeros are plus and minus √7 and you have a minimum value of -5? For this question, have they told us what the vertex is? They haven't explicitly told us, but if we sketch this out, look at what we see. So let's assume -√7 is here. and positive root 7 is here. And I know my minimum value is negative 5. Now, in a parabola, we know the minimum value is the lowest point of the parabola, right? It's the y value of your vertex. We also know that if you have an equal amount of units to the right and to the left, what do you think the axis of symmetry in this case would be? Sarah? Yeah, that's okay. It would be a 0. So it just so happens in this question that your vertex and your minimum is at 0, negative 5. One of your x-intercepts is here and the other x-intercept is here. So really, in this question, you could solve it using factored form or using vertex form. Okay, let's write down all the information that we've just been told. One of our x values is positive root 7. The other x value is negative root 7. One of our points, which is also our vertex, is 0, negative 5. So this is your vertex, but it's also just a point on the graph. If you were to use vertex form and if you were to use factored form, you get the same answer. You can choose what you want. Just because factored form is new, that's the one I'm going to show you so we can get a little bit more practice on it. And I think it actually is easier in this question with all the roots. So we're going to go y is equal to ax plus root 7 and x minus root 7. Our y value is negative 5. Our x value is 0. Okay, so this does require you to remember a little bit about radicals. Do you guys remember what happens when your roots are exactly the same and you're multiplying them? So root 7 times root 7? Yeah, so it actually works out really nicely where you get a whole number 7. So you're going to get negative 5 is equal to negative 7a, and then a is going to be equal to 5 over 7. Did anyone try doing this question with vertex form? If you didn't and you want extra practice, you could go ahead and try it. You could pick 0, negative 5 as your vertex, and then pick one of the points, like one of the x-intercepts, and solve it. Now, if you guys have done handout A, actually, I'll pause right here. Sarah, go ahead. So last class, some of you guys, when you were doing handout A, did I scare you, Ben? Did I just wake you up from your nap? He's like jolted up. When you were doing handout A, I know some of you guys were getting a little frustrated with the graphs and you noticed that the graphs were like really squished and stuff. I wanted to show you 2 examples of graphs that I would actually give you on an assessment. They're going to be super clear like this, okay? So you don't have anything to worry about in terms of like, can I see the points and stuff? I'll make sure they look really, really clear. I'm going to be forcing you to do some stuff here. I'm going to force us to use vertex form for this question. And I'm going to force you to use factored form for this question. And I can do that in an assessment. Like I could give you a graph and I can say, tell me what the equation of this parabola is in factored form. And then that's sort of kind of pushing you towards one of the forms. All right, so in this the first question, we can see our vertex very clearly. And it is going to be negative 8, positive 4. Marzuk, did you have a question? And then we can see one of our points very clearly. And I do want to mention that for some reason, in all of the examples we've done, the points have been on the x-axis, like an x-intercept. That doesn't have to be the case. You can pick any point in the parabola. It doesn't have to be on the x-axis. Like it could be random as well. But this one is on the x-axis, and it's going to be negative 10, 0. Okay, and then go ahead and solve. I get negative 2 squared plus 4. And I move this over and I get 4a. So a is going to be equal to negative 1. So take your time finishing this, but I'll just give you a second, actually. Okay, so I got a is equal to -1. Did you guys get that as well? Okay, I put it into the equation. Now, when I go to check my graph, a value of just -1 means our step pattern should be 1, 3, and 5, right? There's no stretch or compression. And at first, it looks like that doesn't match. However, you have to be careful of the scale of the graph. This graph is going up by 2s. So technically, this point that I've outlined there is 1 to the right, down 1, 1 to the left, down 1. However, if we had made the scale once, it would have been too easy. You wouldn't even have to do the work. You could have very clearly seen that. So that's why I try to pick graphs that aren't obvious. So you have to use the algebraic method. Okay. All right. Second last example. Let's figure this out in factored form. Technically, you could have used vertex form for this because the vertex is given, but let's just use the other form. Okay, so I will go through this again with you guys. We have our x-intercept. So one is x is equal to -7, and the other one is x is equal to -3. And the point that I have on the graph is -4, -3. So I'm going to write y is equal to a x plus 7 and x plus 3. This is going to be -4 is equal to, sorry, -3 is equal to -4 plus 7 and -4 plus 3. So once again, you end up getting a is equal to 1, except in this graph, you can actually have seen it right away. Like you didn't have to do any of the work to see that. But if I'm asking for it in factored form, you would still have to do it algebraically. Actually, no, you wouldn't have to, but we did it. That's what we get. All right, so if we analyze this graph, we can see a couple of things. I can see that my x-intercepts are really clearly shown. However, can you figure out the vertex in this question without guessing? No, you can't, because like, is it -0.25, comma, -1 point, like it's too hard. The vertex is not very obvious. So in this question, I'm forcing you, or the graph is forcing us to use factored form. There's no other form that you can use. So let's go ahead and finish this off. And there is one other point that I want to make after we're done this question. So it's x, one of the x's is -1, the other x is a half. And if you're wondering what other point you can use, there are actually a couple. There's 1 point here, 1 point here, another one here, and another one here. Feel free to use any of those, whatever your preference is. Some of you might want to use 0, -1. I prefer when my numbers are all positive. So I'm going to go ahead and do this question using 1, 2. But really, if you use any of the 4 points that I've highlighted, because they're really obvious to see, you would get the exact same answer. So the 1, 2 is here. -1.5, 2 is here. 0.5, -1 is here. I would avoid all the fractions. And then another good point is 0, -1. You could have used that as well. All right, so let's do this question. We have y is equal to a. And then inside the bracket, we're going to have x plus 1 and x minus a half. My y value is a 2. My x value is a 1. Whoops. And I end up getting a to just be equal to 2. but we're not done. Da, da, da. I'll give you a second until you get to this answer. Did you guys get A is equal to 2? Okay. Now, when you rewrite it, you get it into this form, but I have to mention that this form is very poor format. And the reason for that is we never write a factor that has a fraction inside of it. So see how it says x minus a half? We're like never used to seeing that. We don't see that. Even when we factor something, we don't have that. So how are we going to solve that problem? What we're going to do is to get rid of the fraction, we're going to multiply each one of the things inside the bracket with the denominator. And so we end up getting y is equal to 2 bracket x plus 1, 2x minus 1. Just to show you that this works, because I have to prove it to you, if I were to solve that bracket, I would end up getting x is equal to a half, right? If I were to solve this bracket, I would get 2x minus 1 is equal to 0, 2x is equal to 1, and x is equal to half. So either form, both of them give you the same x-intercept of a half. However, we never leave a factor with a fraction. You always want to have it written like 2x minus 1. Okay, now we're done. There are some textbook questions for you guys to try, 192 numbers 1 to 10. However, I have a feeling handout A is probably not done because I did give you a lot of questions. So I was planning for the rest of this class, like the next half hour, for you guys to just continue handout A. Sarah?